Hello, hi. All right. So nice to meet you all. And very excited to be here. Buildathons are so energizing, and I mean, I've been going through the tables one by one. I haven't had the chance to speak to all of you, but I'm so excited about all these amazing solutions you're trying to come up with. I met this team that's trying to do like a VR documentation and like a virtual tourism of our ancient sites, with like a, I mean, so much of this seems like science fiction, right? For like, if I were to think about some of these solutions, maybe 8-10 years ago, it really feels like we are living in a science fiction reality. Now, that brings me to today's topic about how we could use Gen AI with whatever tools that we have today. What's possible today? What I think is we with technology always try to push the boundary of what feels like science fiction and what is reality, right? I mean, there's VR question, all of those things. Now, the boundary has been pushed, and today we want to just share a little bit about what was previously like a task that would take 5 years of your time, research, some GPUs, some AI engineer doing some mumbo jumbo coding, right? Now to arriving at a point where you don't really like a single developer is able to build an app that does all of those black magic things within an hour, right? We were able to demonstrate. So, Sainesh and Gauri and Ishaan will elaborate a little bit more about that. Now, see, out of the 3 stages of innovation of, you could be in a problem definition phase, you could be in a solution finding stage, you're trying to come up with a, you may have a well-framed problem, but you don't know what the right solution is. You may even figure out that, a good solution would satisfy such and such criteria, but you don't exactly know how to build it, and there's prototyping, right? So we're going to talk about the how part of it today, right? Now, I just want to show you a little web comic that was doing the rounds of the internet from XKCD about 10 years ago. A user takes a photo, the app should check whether, so this is a product manager, okay? And this is the developer. When a user takes a photo, the app should check whether they are in a national park. This is a requirement, okay? The developer says, sure, it's easy, it's an easy GIS lookup, global information system lookup, give me a few hours, okay? Now, the product manager says, and check whether the photo is of a bird. He says, I'll need a research team and 5 years. Okay. This comic book was funny because this was science fiction. This stuff is science fiction. 8 years ago, even 5-6 years ago, you would really need a team to do things like this. Today, something like this and much beyond this is you're able to build these things within an hour, maybe sometimes give or take a week, not more than that, and not in a team. Sainesh was able to ship an amazing application. So we took I don't want to spoil it, but he was able to build out one of the former problem statements of Kumbhathon 10 years ago within 40 minutes. Like he was able to get to a 50% mark, and I think that is remarkable. You could save months or even years of your time by leveraging some of these new tools. And now the previous example can now be built in an hour. I would hand over to Gauri to elaborate exactly how that works, all the cool magic stuff, and please feel free to look up some of the tools that she is mentioning, play around with it, and I mean, post session as well, next couple of days, feel free to pick our brains about this. I'm so excited for what you guys built. Thank you so much.
Really exciting to meet all of you, and likewise I share a lot of Nilay's sentiments. I walked around as well a little bit and figured out that there were teams working on amazing tools. So that is a great segue into trying to talk about the life cycle of integrating generative AI into the products that all of you are trying to build today and within the course of the next 2 years for the Kumbh Mela. So I want to talk about how generative AI can be integrated and what should we be thinking about? What is the life cycle of this integration? Starting with benchmarking your like a data set and evaluate the performance of your model. That's what I mean by benchmarking design. Second, using raw models that are out there. I'm sure everyone's familiar with ChatGPT. I'm going to go through some of the stages of innovation that Nilay mentioned and mention tools for each of those stages of innovation. So like some AI tools that could help you ideate, some AI tools that could help you figure out and prototype and code faster. And then followed by prompt engineering. How can you do this better? How can you improve the performance of your model with in-context learning? Again, something that Ishaan will be explaining more in detail. And fine-tuning the model. I'm not sure if all of you will require fine-tuning an AI model. So Ishaan will talk a little bit about like what are the cases in which it is required and what are the cases in which you can do without it. And then finally, I don't know if we'll get to this, but pre-training and AI research. So let's just jump into it. There's some cost considerations to all of this, of course. If you are integrating raw AI models or tools that are available, or if you're doing prompt engineering using these tools, you have to be mindful of API costs. Especially as a startup. And then, of course, if you are looking into fine-tuning and beyond, you might have to invest in GPUs, maybe even hire engineers. Of course, it gets a little bit more technical as we go down this life cycle. Okay, very quickly, what is benchmarking design? Good AI integration starts with, like I said, a standardized evaluation for your AI model. So debugging for AI integration is effectively rapid experimentation in quick numbers. So let's say, for example, you want to start with thinking about how you will benchmark this AI model. You could start with a very simple toy problem to see if the LLM actually works on this, like just the raw LLM model. And then you can iterate and make it increasingly complicated. And I will give an example of that. And then finally, you can enumerate all of the scenarios that match a real-world example. And that would be your benchmark data set. A more concrete example here would be, let's say, we had one of the speakers earlier talk about like the crop, one of the famous crops of Nashik, onions. So let's say our problem statement is, can we localize onion farms from satellite images of farms? Can we figure out where onion farms are in this satellite image? So our input, obviously, is the image, and the output is the location of the onion farm in the image. Everyone with me here? Yes. So a simple version of trying to figure out and benchmark this model could look something like, maybe you have a black dot on an image, any random image, and you want to check whether your model can actually identify that black dot or not. Very simple, right? And then, of course, you can go ahead and make it more complicated. Maybe the next step could be not just any random image, but I want to pick a satellite image and pick a red label or a white or a black dot inside this image and locate it accurately. And then further, making it more complicated, can we locate simple boundaries and segmentations of this image into figuring out whether there is a farm in the image or not, and so on and so forth. So as you can see, you can make more and more complicated versions of this, and final benchmark will form a useful test case for the AI model, such that if other people were to solve the same exact problem, they can test their model against this benchmark as well. Okay, on to the fun stuff, which I think a lot of you are curious about. What are AI tools that I can actually use for each of these stages of innovation? Trying to ideate and brainstorm on my problem definition, trying to find the right solution, and finally trying to prototype my idea and bring it to market. So here, this is a very text-heavy slide, but it includes some of the tools that all of us here have used. And when Sainesh shows his prototype, which he built in 40 minutes, this was built using a lot of the boilerplate framework that I've given in this slide. So for problem definition and ideation, of course you can use, your raw AI models like GPT-4, Claude, just the pre-trained models, and ask it to help you ideate and come up with a better and more structured problem statement. You could also, use smaller models and such as Facebook Llama, or you could use a tool like Microsoft RD Agent, which is a LLM agent that actually takes you through the entire life cycle that I mentioned in the previous slide. And then for solution finding, of course, the best way to find a solution for your problem, as I'm sure a lot of the previous speakers spoke about, is talk to your users. Don't skip that step. That's very important for identifying product market fit. But of course, you can also then use AI tools that help you augment the customer discovery process itself, like identify who could be the stakeholders for your app. And some of these we've mentioned here, like Tiny Troop, Try Cairo. If there's others that students here have tried, feel free to come and talk to us about them. And then finally, here's a framework that I have given, because this talk is finally about rapid AI prototyping. So here's a framework that we've sort of come up with that you could use to rapidly integrate AI into your prototypes. The first, of course, is planning and designing. So maybe you want to build an end-to-end application with a UI. So you could use Figma and with their generative AI templates for app design. And you can also ask LLMs such as Perplexity to help you come up with a system architecture for your application. Finally, to build components of your prototype, you could use tools that are out there such as LangChain, just basically sort of a wrapper across a whole bunch of AI tooling. That's what LangChain offers you. And it's an easy way to build LLM agents with a lot of tools. We sort of differ on the usefulness of it a little bit, but LangChain is one of the tools. OpenRouter, Fireworks. There's endless numbers of tools here. Hugging Face, of course, if you aren't familiar, is a great place. It's like GitHub for ML. So in GitHub, you can collaborate on code. In Hugging Face, people collaborate on models, on data sets. So if there is an application that you have in mind, it won't hurt you to go on Hugging Face first, figure out if there's a data set for a similar application that you can use, and then also figure out if there are pre-trained models on the Hugging Face platform that people have used on those data sets. It's really a great resource. And then finally, once you have figured out your plan and you have an idea of what data sets you're going to use for it, and what model, pre-trained LLM that you're going to apply to your model or pre-trained vision model, then you can go check out some of the coding tools that we've mentioned here, such as if you are an experienced coder, you can obviously try Cursor. How many of you have tried Cursor here? 1, 2, 3, okay, not a lot of people. So Cursor is my favorite coding. Okay, Nilay's favorite too. I think that gets more points. So it's really an amazing tool. It basically it integrates a lot of your favorite large language models within the VS Code coding platform. It's like GitHub Copilot, but with a whole bunch of Claude 3.5 Sonnet, all your favorite models essentially. And then what you can also do, which is my favorite feature of it, is you can give it your entire code base as a context, and then ask questions. And maybe if you have a feature request, you can type it in natural language and have, and have and have Cursor IDE implemented for you and apply those changes directly into your code base. So very useful tool to expedite the process. And finally, for any no-code solutions, you can try out Stack AI and Windsurfer Editor as well if you're less experienced with coding. And that's all. I think the next slide we have is for you. Okay, the next demo we have is Sainesh's demo, and I'll let him explain what that is about.
So Just to clarify, like we went through all these tools, and Sainesh has built something that integrates a lot of them, and we'll show a quick demo before we move on to understanding some of these things.
Yeah, so we wanted to put our money where our mouth is. We did it in 40 minutes, and we tried not to code anything. So I haven't changed anything. I have not written one line of code. Even if I wanted to change something and I could see it right there, I didn't do it. I gave it back to GPT. I made it do it. And so let's go to the application first. Right, so this was one thing which Nilay was talking about. Last time when he came to this hack, they were trying to make something like this, which was basically taking people's unstructured medical data, like what you are feeling, what your symptoms are, and then converting it into structured data. That could actually help doctors understand what zones are becoming, what zones are probably, they have some medical problem that's erupting there. For example, in today's time, probably some zone has COVID. And so they can look at data and they can see, okay, 30 people here are developing sore throats, 50 people here are developing stomach aches, stuff like that. It's really helpful so that we can mitigate, as soon as possible. We could provide medical treatment there. And this was not possible, I think 9 years, 10 years back, it wasn't possible at all. And right now, it took us 40 minutes to make it. And it's not just us, you could probably make it in 30, I don't know. So let's go through it. Now, even for the symptom, I'm going to use, I don't want to write anything, so let's use this. I just told it to give me some symptoms for COVID. And so there are 3 ways to do it. Since it's also a tutorial and we want to talk about 0 shot, 1 shot, few shot, there are multiple ways to do it, but let's focus on few shot right now, which is the best way. So it's broken down my problem, which is what I'm feeling right now. So I am feeling sick, this is what is happening with me. It's broken down into symptoms, descriptions of the symptoms. And now where this is useful is while I'm coding solutions for this. So I can actually use this data somewhere. I can actually, since I have data in a structured way, and I know for sure it's going to be in the same way, I can see what the symptoms are for everybody in that zone. So, okay, 6 people are getting headaches, 3 people are getting this. And so it's really easy to, get data in a structured manner, which is a very big step. This is not possible 9 years back. That's how big this is. And right now it's taken us 30 minutes. And how did we make it? It was very simple. GPT it is. And yeah, I just asked it for example. I just gave it a description. And even the description, by the way, I asked GPT to generate it. So what happens normally is we have an idea in our mind. And we just give it to GPT and we try to get the code out of it. And we won't get the best solutions. So the best way to do it is give it to GPT, let it make a prompt for you. Then use that prompt to make an architecture. And then try to break it down into as small as possible, steps as possible. And then code that. And so that's what's been done here. It's literally a 100-line code, out of which I've written 0 lines. I've not even written pip install. I asked for that as well. So that's how easy it is today. I'll make the code open source, so anybody who wants to use it is free to use it. And yeah, that's about it. I think Ishaan will be explaining 1 shot, few shot, which is what is there in the application itself. So yeah, thanks.
Okay, so while it's lovely to talk to everyone today, yeah, it was likewise, as Nilay said and Gauri said, it was awesome to see some of the ideas that are being executed, and there's the excitement is palpable. I can see that there's a lot of cool directions that people are exploring for this Kumbh. My goal with this side of the presentation is basically to give context for everything we've spoken about, tell you a little bit about how language models actually work, and without getting into too many of the technical details. So language models are powered by neural networks called transformers. We won't actually be studying transformers, but we'd just be looking at the input-output behavior of language models to help us use them in a better way. So all of the tools we spoke about, including GPT-4, Llama, some of these LangChain tools, they have a language model behind them, and in order to use them effectively, know what to expect from them, we should be able to really understand at a high level picture what's going on. So just 2 slides, an extremely simple way. What language models really do is they are trained on a task called next token prediction. So on the internet, you have large amounts of sentences. Every day we speak hundreds and thousands of sentences, and each one of these sentences is creative in different ways. We say some for just communication, some of these sentences involve logical reasoning, some of them involve knowledge, like the capital city of Maharashtra, for example. And all of this information is prevalent on the internet. Language models are trained to basically predict the end of the sentence from a beginning of a sentence. It's a task we do as humans often. And so for a very simple example, here, the introduction, the starting token is like this S, which indicates that you're starting the sentence. The language model is trained so that it produces one feasible next token, like the word the, right? And on the next step, it's going to... And on the next step, what's going to happen is that the predicted word is going to go right here at the bottom, and it's going to predict the next word. So I'll need to play the... Yes. Yeah. Okay. Well, that was a lot for just 2 words, but and so one feasible word could be thing, and then the language model is rolled out like this until we have all 1,024 words. And then what we want is that the sentence it generates should look like a realistic sentence. So it's literally as simple a task as it can be. It's being asked to complete your sentence from any given point of time from an incomplete sentence. Yeah, we can go on to the next slide. And so what happens when you do this is LLMs end up learning the knowledge, the intelligence that they have is essentially an intelligence of statistical association and co-occurrence. They know, for example, that words like dog co-occur with words like pets or words like cute, because these words co-occur in sentences often, and real sentences contain these co-occurrence relationships. And so what we can expect out of them is a natural consequence of the fact that they are trained in this way. So things that co-occur very, very obviously are knowledge, right? Like, so if I ask you in a sentence, what is the capital of France? Right, everyone will say Paris because they know it's Paris, and France, capital, what is the capital of France, and Paris will always co-occur together. So questions of knowledge, language models almost always get correctly. So if your application involves using knowledge that's found on the internet, then language models can serve as really useful search engines. So things like symptoms, which was demoed inside, this is common knowledge now. WebMD has a lot of information about symptoms. It is a matter of knowledge, and we can expect language models to do very well. What kind of bird a certain image has is a question of knowledge, and that was in the meme that Nilay shared before. Because it's a question of knowledge, we can expect it to work reasonably well, because those images of birds will always co-occur on the internet with language that indicates what bird it is. For example, a chicken. And so when you have an AI application that involves some sort of knowledge recovery, then you can definitely do LLM integration, and we can reasonably expect it to work. Lots of examples, and you can get away with testing it sort of minimally in the way that you need for your application. Now, there's a next more advanced stage of abilities that language models have, and that's pattern-based reasoning. So we do this in school with things like simple arithmetic, calculus, how do I take a derivative, or how do I integrate. Many of you are in 8th, 9th grade, you might be looking at some of these concepts. We do it for pattern recognition exams where you're given like these IQ, symbolic logic things that you do. And then we do it for things like analogies and syllogisms, which are common in usual language. And so for a long time, language models struggled with these sorts of tasks because they involved one step beyond knowledge. So if you know how to add numbers 20 and 40, you should be able to add numbers 40 and 80, for example. But because there's a large amount of data present on these things as well on the internet, language models have gotten really good at pattern-based recognition, even though they're trained on next token prediction, because the only way to predict the next token correctly is to implement the exact algorithm that these simple tasks care about. So if you have tasks that involve some simple pattern-based reasoning, like the pattern has been found on the internet many, many times. For example, Stack Overflow has lots of patterns of doing code, writing good code, or like Math Overflow has a lot of patterns of doing good arithmetic and math problems. Then this will likely work with good prompt engineering, but you have to be a little bit more careful and test on a wider range of scenarios. Now, The final kind of reasoning that language models usually struggle with, and you'd have to work harder to sort of think about how to get this into your applications, is things that involve symbolic, structured, or long horizon reasoning. So, for example, we're really good at saying, okay, I've seen a whole movie, now tell me who the most two important characters were or how they interact. It involves taking in lots and lots of data and then analyzing some complex relationships, having several orders of reasoning, not just adding two concepts, but compositional reasoning about many, many different concepts together. This sort of stuff shows up with things like complex riddles, and also shows out of things like natural symmetry. So if I'm trying to like grasp objects, for example. And this is much harder to get to work because this data is often not found in the on the internet. We can hope that this data was in the training mixture and still try to get something to work here, but this needs a lot more advanced prompting, perhaps fine-tuning, some AI research, and often involves a lot of rigorous testing. So my goal with this slide was to let you know that when you start off using a language model, any of these tools, depending on the context and the application that you're developing, you should probably be optimistic or cautious with how you integrate Gen AI. You should definitely try, but you should know exactly the pros and cons of what the technology that you have at hand. Cool. So now that we have this out of the way, I want to show you how you can use the fact that LLMs are trained on next token prediction, or that they're trained, or that they model these statistical co-occurrences, things that like words like dog appear with cute and France appears with Paris, in order to help you solve your cause. Because knowing that language models work like this is exactly what will enable you to use language models effectively. So prompting is essentially becoming friends with this insight. It's constantly reminding yourself that what the language model is doing is statistical co-occurrence, and so we should ask questions that will allow it to do what it does best, which is statistical co-occurrence. So consider this question, like, classify the text into neutral, negative, or positive. Text, I think the vacation is okay. Sentiment, it has a fairly obvious answer. That's a neutral, I'm not saying, oh, the vacation was amazing, I met great people, I had good food. And it's not saying, oh, I had the worst time of my life. It's just saying, it's fine. And so that's the neutral outcome. And many people use language models in this way. This is the 101 of, I have some input and I want some output. This is how you'd use Google. This is how you'd use some other forms of, this is how you talk to a person, maybe. But here's another way in which you can take advantage of the fact that statistical co-occurrences are what power language models. You can give it a bunch of examples. You can say, this is what I call positive, and this is what I call negative. So this is what people call few-shot prompting, and this is like when people who use language models regularly were introduced to this, like, oh, in some sense, this is just a very natural insight, and it is, but it's kind of nice that this works so well. I can say, positive, this is awesome. This is bad, is negative. Wow, this movie was rad. Positive, what a horrible show. And then you say, okay, what's the output? So when the language model is forced to output something, not only does it have a question, but it has a lot of understanding of what you consider to be positive and negative, right? And so you've given it like sort of more context to reason correctly. Sorry, could you go back to the previous slide? So yeah, the ability to do, this ability of language models is called in-context learning, because essentially, if you now have like a new data set or new examples, you can give these examples in context, and then just have your final question as the final prompt, and have the output of the language model come out. Now, what's another natural way of like taking advantage of co-occurrences? What do we do when we write math exams, right? How does data on the internet often show up? It shows up in the form of method, right? Like oftentimes you'll hear a teacher saying, oh, I won't give you full marks because you have the right answer, but you didn't have the method. And one natural way of taking advantage of language models is using prompting that has natural methods. So, for example, I could just ask the language model this final question. The odd number in this group add up to an even number, and just give this, and it would not know what to do. It might perhaps get this answer wrong. But I could, for example, now give examples of this exact kind of question and answers for many different steps, and that would be few-shot prompting. But we can do one more step here. We can say, give the question, and then actually show how you do the answer. You say, okay, adding all the odd numbers, select the odd numbers is 25. The answer is false. So now you give it a structured way of reasoning about what you're doing, and now it makes this whole co-occurrence problem somewhat more natural. Like this is data will show up like this on the internet. So you can use, and so this is called chain of thought prompting. Yeah, it's been very effective. Now I won't go into the details of these images here. The point was to basically say that people have used this natural insight of how language models are trained to design very, very advanced prompting strategies. You must have heard of retrieval augmented generation. I think this is like knowledge integration prompting. There's many, many papers about this, and like this is a very active field of research. All of it depends on this insight that like this is how LLMs are trained, and this is why this is a natural way of talking to them. So using more context, using more detail inside context, even though it seems a little bit obvious, it follows very naturally from how the LLM was trained, and you should use it to think about whether the LLM is a good solution for your problem, or like any Gen AI tool you're using that's trained in this paradigm. Okay, and lastly, I want to use one slide to talk about fine-tuning and AI research, because people are often excited about this. People think, oh, I have a very specific application. I might be translating into a rare language that is nowhere on the internet, and so I must fine-tune, or I might be, like classifying some satellite images, and satellite images are very rare on the internet, so there's no way I must fine-tune. And so I want to give a perspective on when you should actually invest in fine-tuning and research. Gauri's diagram, where she had fine-tuning and research at the very end, shows you that this is an expensive undertaking. It involves significant investment on the part of your startup, including potentially hiring AI researchers or engineers. And so I just want to explain to you what it actually is. So fine-tuning is the process of updating the large model, the huge model that was trained at scale on the internet, on a fixed new data set. So first of all, this needs a very large new data set for what you're doing. It does not make sense to fine-tune a model with very little data set. There are exceptions to this, but usually we expect that we have a nice, good data set that changes the representations or properties of the model. I already mentioned this. It needs understanding of modern internals and fine-tuning techniques, and it's expensive. And finally, when you fine-tune stuff, you usually want to do it yourself, because even though lots of these companies have fine-tuning APIs, there might be privacy concerns you have with sharing your own data. So the point is to say that fine-tuning is an expensive undertaking. But there are some cases where it's needed. One case where it's definitely needed is where the base LLM does not share the language that you want to operate in, right? So the tokens associated with a language like Marathi, like ChatGPT does have it, but say for example that there's a new language, it's a robot language, and you want to talk to a robot, the LLM has never seen these new tokens. At the end of the day, the LLM was trained to predict one token from the next token, and it has a fixed vocabulary of tokens. So if like the token that you're trying to predict has never been seen before, the LLM is not going to be able to predict this token. You cannot finish sentences in a language you've never learned. And so that requires fine-tuning. And some of the harder things that I've spoken about in the past, like if it involves a whole new form of structural reasoning, example like science research problems, that might be another reason why fine-tuning is required. So fine-tuning is useful. My point with showing the prompting and showing all these other techniques was to say that fine-tuning is now a much later stage in your development cycle than it used to be. Like 2 years ago, if I was training a new model, or if I was trying to do a new model, I would instantly go to fine-tuning. But with the abilities, the pattern-based reasoning abilities of like large-scale LLMs, fine-tuning can be deferred until you've tried simpler things and just sort of gone through the API and prompt engineering cycle. And so the takeaway is sort of start with prompt engineering, try to capitalize on the statistical co-occurrence capability. Like keep in mind that this is how the model works. Try to understand the model. If you have more time, go and read all these amazing blogs that there's like on how LLMs actually work. Don't under or overestimate the power of reasoning that's possible through language. So be highly empirical. Try to integrate with Gen AI. Fail fast, but like don't like know exactly what it's really good at and what it's not that so good at, and only fine-tune if necessary. And so that's basically what I have to conclude from these slides. Thank you.
Yeah, all right. I mean, that was the session. Thank you. I mean, just to close this, right, like, the point is what you were able to do without having AI expertise maybe took you from 0 to 40 10 years ago. Let's say the ideal solution that you had is like this robot, whatever it is, right, ekdam AGI science fiction level stuff, right? If that is 100, with not knowing how to build AI, all this AI research and machine learning and calculus and all that, maybe you'd be able to hit like 30 or 40 levels, maybe 3 or 4 years ago before GPT. After this, the boundary of what you could do without knowing AI has been pushed to probably like in the high 70s or 80s, right? And I mean, that's the biggest, whatever I would say, like the playground that has opened up for us. right? This did not exist before, and I think that's why like we should leverage this opportunity as much as possible. All of this, there's a lot of reasoning and thought given to how we use these LLMs. I encourage all of you to play around and find out for yourself for your use cases. There's multiple tools. Play around. There's a huge realm of possibility unlocked. Some of the problems that you think are very hard may not be as out of reach as you think. Maybe if you think this thing is going to take 5 years, it might be a week-long or a 2-week-long experiment for you. So I heavily encourage you to hack, to build, to actually see it in action for your own use case. Yeah, that's it. Thank you so much for the time.
Just a request, you explain like where did you enter the prompt, few short prompt, where did you make it? So you picked a prompt from ChatGPT, and where did you pasted it, where it generated the code. So explain that step, and also can it run without ChatGPT kind of background at the end or not? Because if it is running on ChatGPT, then you are actually not creating new.
No.
Nobody will pay you for that.
So it's not running on the UI of ChatGPT. It's using APIs, right? So what happens is there are many ways to use LLMs. One is if you're not building something, if what you're doing is you're using it for your own personal use case, you use these GUIs, these this websites and stuff like that. But if you're using it in your company, you're allowed to do it by using APIs. And so that is how we did it. Here's how you enter the prompt. This is our code. Oh. Can you display my screen? Right, so this is the code file. As you can see, so it's all Python code. And what we are doing here is, we didn't show this, but we were doing all three. You could see all three. I'll share the code so you can go through it. Basically, how it works is, I have defined the prompt here in my code itself. And when I make an API call, that is when I'm calling their servers, I give my code, I give my prompt to it, So here's how I'm calling it here.
See, in my view, if you would have run it on a Streamlit, for example, then I would have called it like a new application. Otherwise, if you're running on ChatGPT, then it's like using ChatGPT only.
I had called it on Streamlit. So this is Streamlit. Thank you for liking my UI, but this is Streamlit. This is not GPTs. Yeah, this is I made it in 40 minutes. Thanks.
Yeah, I also want to answer like a broader question that you raised by asking that question, which is that at the end of the day, the language model that you're calling is a ChatGPT call, right? So you might have some angst about the fact that, I'm just using ChatGPT, and isn't ChatGPT like a different model, and how is that new AI? So I do think that there's a lot of value add to be had by like understanding ChatGPT or any one of these language models in very specific contexts. So if you're developing for a particular application, you're going to learn a lot more about that application that just a naive use of ChatGPT will not enable. Things that go into your prompts, things that potentially go into fine-tuning, that go into designing the right workflow of applications, composing these models together. They're going to provide the novelty for your application that, like, in addition to, of course, the fact that the UI is nice and you can also have a wrapper. Like, there's also actual research and work to be done on getting these models working for you. And sort of the point of like talking about what LLMs do and how to think about this prompting is to say that it's not the end all, right? It's not just input in, output out. It's also saying there's a whole infrastructure and like things to be done to get it working really well for your application, even though it's easy and fast to iterate on and integrate with.
Small question here. See, if you create what we call ChatGPT or LLM model, whatever, you give 3 lines, it converts into say 15 lines. Yeah. And I put it on my blog. And somebody asked me a question, so how should I prepare? Should I be prepared for the 15 lines or should I be prepared for 3 lines only?
I didn't get it. Can you?
Yeah, see, I give 3 lines. I say go on expanding. It expands into say 35 lines. Yeah. The 3 lines input prompt, it expands into 35 lines. It goes into different models, it goes into that. Right. I shared it with my boss. Say, this is the work I have done. Karke. Yeah. Okay. So my boss thinks, okay, Prashant is very good. He has made a large presentation. He starts picking the question. He starts questioning that, whatever I've shared with him. The 35 lines I've shared with him.
I can't hear you. Is it not audible? Did you?
I understand. Okay. So your question is, if you're trying to expand something,
Yeah.
and you have like an expansion,
Yes.
are you asking how your like application should be prepared for it, or how you should be prepared to
I should be
explain what
prepared. I should be. How should I be prepared for the any questions coming?
That's
out
a
of-
really good question, right? I think what you're raising is that sometimes in life we're trying to solve under constrained problems, which
Yes.
is that you only have access to a certain partial view of the thing that you've told, and you want like a more complete view.
Yeah.
So for example, one under constrained problem we all are solving right now is I only have if I close one eye, I have a 2D image of this scene, but I'm inferring the whole 3D, correct, of 3D structure of this room. And it's similar, like you're saying, okay, I want a large something that compresses into the 3 lines that I wrote. So it's an under constrained problem.
Yeah.
And so whenever you're trying to solve an under constrained problem, you have uncertainty. You don't know what goes into, like, you know, maybe someone's standing behind you and hiding behind you, and I won't be able to say what's happening in 3D, right? So it's sort of a natural artifact that these models, because they're predicting next tokens, tend to fill in things, right? You're saying, right? And I think the only way to be prepared for it is actually looking at the output, like saying, okay, this is what it produced. Did it align with what I want to say? Because it's going to imagine or hallucinate certain things.
Exactly.
You know, it's as I said, it's not an end-all solution. It's great if you want to say, okay, I want to fill out a 500-word essay with a one-line idea.
Yeah.
But you now need to make sure that all the 499 lines that it's thrown out is consistent, it's aligned, and so on and so forth. And there's people at OpenAI working to make sure that those 499 lines are not harmful. For example, they're trying to say, okay, we want it to be aligned with good human values.
Yes.
But I think whenever you're using any AI tech, the user has to be very, very important. The user needs to be aware of the fact that this, like, you might be trying to solve an under constraint problem. This is opposed, for example, to summarization, which is exactly the opposite. You have a lot and you want to condense into a little bit, right? So, yeah.
Thank you.
Hey, Ishaan, Nilesh, Sainesh, and Gauri. Thank you so much. So this has been a great event so far. And as a mentor for Kumbhathon, I have been interacting with few startups. So first of all, this session was very informative, right? And I believe that many startups who are trying to build AI application will definitely be looking at it. Could you please go to the fine-tuning slide if it is possible? Okay, perfect. So, this is going to be a major problem and breakthrough. The thing is, when we fine-tune, when we use a private model, let's say, right? We use llama models, we fine-tune it because we don't want to use a GPT, let's say, model for that, in case. The problem comes in model serving and model inferencing. Now, how exactly, and this is an open question, right? Because it's not a rhetorical, but it's an open question so that you can address it for the larger audience. So let's say people are building these models, they fine-tune it. As you created an example, a symptom tracker, right? You can use your own model and you can serve it from your computer using Llama or VLLM, right? What exactly should be the mathematical breakthrough where you understand that if you want to use these models as an inference instead of GPT, right? Because inference is again going to be a bigger change when it comes to model serving and model inferencing. So if you can reflect on that part and tell people that, fine-tuning is one part, model serving, model inference is also equally important when you talk about scalability of, usage of AI. So, because cost is again a factor. But again, thank you so much. This has been a great session so far.
Basically, what you do is, so it depends on the problem statement more than the model itself. So if you're dealing with something which is really critical, so if you're dealing with something which is somebody's health information or some financial information, so you will go for fine-tuning. Even if you're around 90% of the times you're correct, that's not good enough for you. It looks really nice in projects, but it's not really usable in the real world. And so you'd have to integrate some static tools along with it. It's even a part of my research. I'm doing something like that. And we have to do it. There's no other way. It looks really nice if you're getting 90% results, on papers. But in the real world, it's either 100% or your application doesn't work. That is for very critical tasks. So if anything is really critical, don't use LLMs in your workspace, in your workflow. Probably use it for smaller steps, but they shouldn't be the deciding factor. That's step one. Second is talking about scalability. So when it comes to scalability, I personally think it's always better to go for APIs, because what happens when you use APIs is, it is OpenAI's server, it's their problem, it's their developers. And all you're doing is you're paying 0.0001 for every call. That's actually cheaper than even running your own server and doing it. And I was doing it for one of my projects. If you're not using GPUs and you're using a simple CPU, which is like basically a very simple system, what you're using, your simple inference will take 5 to 7 minutes, even in a smaller model. And so it doesn't make sense at all. And so fine tuning is only for people who are really at the realm of, AI. They're solving the questions to be answered. Otherwise, for everybody else, I think inference is good enough.
I'd just like to add a little bit on this. So let me illustrate with an example. Let's say you have farm data, okay? So, you're trying to detect from sensors if there's a stem borer inside. This is one of the disk questions that I kind of came up. Let's say there's a data set and you want to use an LLM to infer whether there's a stem borer inside based on some sound vibration data. Okay? This data does not appear on the internet, so it is unlikely that the model will be able to make sense of it or give you a good output. So let's say you really want to use an LLM to do this, so you fine tune it. Now the question is, when you fine tune, you still need to be able to run the model. It's like, think about it like games, right? आपके पास CD है, you have whatever GTA San Andreas का CD, but your computer needs enough space to be able to run it, and your laptop will most likely not be able to run this model on its own. Therefore, you have to rent a big server with GPUs loaded on it. You pay up to $2 an hour of one GPU. If it's a very large model, you might need multiple GPUs. Okay, so the costs can run really, really high if you want to serve your own model. There are a couple of, if the model is under a certain limit, like, I don't know, like 24 gigabytes or something, there are platforms that will do on-demand hosting for you. There's things like Fireworks or Replicate, etc., which will host on-demand models, which means that the model, the computer, this so-called computer that you're asking, right? I mean, even this API call jo bhi hota hai, what happens is OpenAI has a bunch of computers rented, and then you send a question and that computer answers this. When you want your question answered, these on-demand platforms, what they do is they boot a new computer for you, they process your request, send your answer back, and then they shut down the computer. So you are only charged for that 1 minute or whatever it is that this, that you use this. You could use this when your use case is not real time, okay? When you don't need, a user isn't waiting for a response. Let's say farm data analyze kar rahe hai aap, ya fir kuch ek aggregate, whatever you're trying to do, or that where you could afford to wait for an answer, you could use some of these more on-demand pay-as-you-go solutions and keep the costs low while maintaining the efficiency and privacy and so on, all the good stuff about this thing. So there's a few, this thing, I mean, I don't know, I don't want to get too detailed into ML ops as such, but it's a field of this thing, and it's more about thinking about systems than AI itself. It's a very interesting this thing area to talk about. Thank you.
Hey, hi. First of all, huge thanks that you gave us a lot of clarity on AI on the surface level. But the similar question, or maybe a relevant question to the previous one, that as a startup, how do we decide that the APIs that we are going to use are the best ones, or it are the best tools for the problem or the specific problem that we are going to solve? How do we decide that? What could be the possible parameters, or maybe how do we measure it? That's exact question. Yeah.
On benchmarking was relevant in this case. I think you want to identify, first, I think you're asking two questions. First is, what API do I pick and how do I know it's the right one?
Yeah, exactly.
And second, if there is a better API that comes along, like how do I make sure that I'm updating my application with this new APIs that are coming in the market? So the first question to answer that is you need a very, very good benchmarking. So you need a data set which you can test your model or test your API performance on, and see how well the model is performing, whether you're getting the results that you want to get, and also compare it with existing other API models that are out there. And then second, when you I would encourage you to build like a system that is API agnostic. So like you can switch models on demand essentially. So that would be, yeah, you can use open routers and other platforms for that.
Yeah, I guess, but it again results on the cost because it's gonna somehow increase your cost in some way.
Sure, fair enough. So the thing is, let's say OpenAI might be charging you like $1 for 1 million tokens or something, whatever it is, right? And the costs are competing with each other. So I wouldn't say that one API is going to be drastically more expensive unless you're using a higher level of model. Okay. Now you have tools like OpenRouter where let's say you expected a response from ChatGPT in a certain format and it doesn't deliver it in that format, right? So things like or ChatGPT API is down, it's not responding, it's too slow, etc. You have tools like OpenRouter where your system can switch between models seamlessly. Okay, so you don't have to care about, or the user doesn't have to care about whether this is ChatGPT 4.0, whether it's 0.1, whether it's Claude 3.5 Sonnet, or it's your own hosted Llama instance. It doesn't matter because tools like OpenRouter, you're able to route this request, right? So if a certain response was expected in a certain time and it didn't happen, it makes it catches this and on the fly it switches to a different, it's like an inverter for your AI, right? कि light चली गई तो inverter पे immediately switch हो जाएगा. So there's ways to build robustness or resilience in your in whatever your solution is in these manners. Like there's fallback mechanisms available for this.
Perfect. Huge thanks. Thank you so much.
One more thing to add there, actually. That's like one way in which you can design your system. And Gauri spoke to the importance of having good evaluation and testing. One really important thing is to sort of always be up to date with what models are good for what. So now, like when GPT comes out, like GPT-4V is like a vision model, so it does very well on visual tasks, of course. O3 came out yesterday that does more test time scaling, so it's good on reasoning tasks. And so when new models come out, they actually come with this branding or model cards that tell you that my model is good for this purpose. And what I would do whenever I'm like testing is I would say I'd take the best model, the most general model like GPT-4 out there. I would take one big open source model like Llama or something like that. I would take one of the state-of-the-art models that is related to the problem you're trying to solve. So if your problem is a very symbolic problem, I do a reasoning-based model. If your problems are very chat-based model, I use one of the chat-based models. And then just create a suite of 3 or 4 things that you're testing, and then don't be too obsessed about the specifics about, oh, what is this model versus doing that model. Maybe that's relevant later down the cycle, but I'm sure that between these 4, like a task special model and 2 of the big models, you should be able to get what you need for your solution. At least an idea of whether your problem is solvable with language models.
Yeah, I guess this one would work for me. Thank you so much.